This videotape deals with solving simple fractional equations. I'd like you to recall how you went about solving simple equations without fractions. Let's look at a typical example. 4x minus 3 equals 12 minus x. Now, when you wanted to solve this equation for x, the object was to get all the terms involving x on one side, all the constant terms on the other, and eventually get this down into the form of a trivial equation, something like x equals some number, which would be the solution of the equation. Okay, let's add 3 to both sides, giving us 4x equals 15 minus x. Now let's add x to both sides, giving us 5x equals 15. And finally, we would divide both sides of this equation by 5, giving us the solution x equals 3. And of course, you could check this. Okay, now when you want to solve an equation involving fractions, everything is the same except you have an extra step in the beginning. In this step, we try to clear our fractions. Then we get an equation without fractions, and we proceed as before. Now, let me put down a typical equation. 3/4 x equals 12. What we're going to do is to first multiply both sides of this equation by a number so that there will be no fractions in the resulting equation, and then we will solve it the way we solve the equations without fractions. Well, it's fairly easy to pick a nice number here. If we multiply both sides of the equation by 4, we'd see on the left we would get 4 times 3x over 4. The 4's would cancel. We would get 3x equals 48. We have an equation without fractions, and we solve this in our usual way. We divide both sides by 3, and we get x equals 16 as a solution. Okay, now you could have multiplied both sides of the equation by 4/3, but let's do it this way. It's very simple, and our first step will just be to remove fractions, and then we will be able to solve the equation. Let's try a slightly more complicated example. X over 2 plus 1 equals x plus 2. Okay, here we're going to multiply both sides of the equation by 2. Okay, 2 times x over 2 plus 1 is equal to 2 times x plus 2. Now, when you're multiplying the left side here by 2, don't forget the distributive law. It's 2 times x over 2 plus 2 times 1 equals 2 times x plus 2 times 2, or 4. It's 2x plus 4, using the distributive law. Over here, 2x over 2. We can divide out the 2's. The 2's cancel. We get x plus 2 equals 2x plus 4. Now we have a nice simple equation without fractions, and we can subtract x from both sides, giving us 2 is equal to x plus 4, and then subtract 4 from both sides of the equation, giving us a final answer of x equals minus 2. And of course, you can check these equations. I'll check the next one. You can check these equations the way you would check any equations. Okay, let's try another example. X over 6 minus x over 4 is equal to 2. Okay, now once again, we would like to multiply both sides of this equation by a number so that we would remove fractions. Okay, now what we need is the least common multiple of the denominators, or the lowest common denominator. Now, in a pinch, you could always use the product of the denominators, 24. If you multiplied both sides of this equation by 24, you would clear fractions. However, generally you can do a lot better than the product of the denominators. If you can't think of something else, remember you can use the product of the denominators in a pinch. Okay? In this particular problem, the least common multiple of 6 and 4 happens to be 12. That's the smallest number that 6 and 4 both go evenly into. Okay, so if we multiply through both sides of this equation by 12, we will get an equation in which there are no fractions. Let's try that. 12 times x over 6 minus x over 4 equals 12 times 2. Now, using the distributive law, we get 12 times x over 6 minus 12 times x over 4 equals 12 times 2, or 24. Okay, now, 12x over 6, that's just 2x. 6 goes into 12 twice. 4 goes into 12 3 times, so we have minus 3x equals 24. 2x minus 3x, that's minus x, equals 24. Okay, now remember that minus x equals 24 is the same as saying minus 1x equals 24. So if we'd want to solve for x, we could divide both sides of this equation by minus 1, giving us a final answer of x equals minus 24. Let's check this answer. We go back to the original equation, x over 6 minus x over 4 equals 2. And we substitute for x the value that we found. X equals minus 24. So we get minus 24 over 6, take away minus 24 over 4 should be equal to 2. Every time we see an x, we write minus 24. Minus 24 over 6, take away minus 24 over 4 should be equal to 2. Well, let's see. Minus 24 over 6, that's minus 4. Take away. Now, minus 24 over 4 is minus 6. This should be equal to 2. And what we have here is minus 4. Now, instead of subtracting a minus 6, we can add a plus 6. Minus 4 plus 6 should be equal to 2, and sure enough, that's equal to 2, and that's the end of our check. Minus 4 plus 6 is exactly equal to plus 2. Okay, for our next example, let's try this. X plus 2 over 3 plus 1 equals 3x over 2 minus 3. In this particular problem, it turns out that the least common multiple is the product of the denominators. 6 is the smallest number that 2 and 3 both go evenly into. Okay, so the least common multiple of 2 and 3 is 6. So we will multiply both sides of the equation by 6. Okay, now when you're multiplying both sides of the equation by 6, it's 6 times x plus 2 over 3 plus 1 equals 6 times 3x over 2 minus 3. Now, using the distributive law, we get 6 times x plus 2 over 3 plus 6 times 1 equals 6 times 3x over 2, take away 6 times 3. Okay, now, 6 divided by 3, that's 2, so we have 2 times x plus 2 in parentheses, plus 6 equals 2 into 6 goes 3 times 3x minus 18. All right, this gives us 2x plus 4 plus 6 equals 9x minus 18. Simplifying, we get 2x plus 10 equals 9x minus 18. And we'll continue with that in a moment. Okay, let me write that down on this board. We have 2x plus 10 equals 9x minus 18. Okay, we can add 18 to both sides of this equation. This would give us 2x plus 28 equals 9x. The 18s would go. Then we could subtract 2x from both sides, giving us 28 equals 7x. And finally, divide both sides of the equation by 7 to get the answer that x equals 4. Okay, let's try checking this one. To check, we'll go back to the original equation, which was x plus 2 over 3 plus 1 equals 3x over 2 minus 3. We're going to substitute in the value that we found, x equals 4, and hope that the left and the right sides match. Okay, x equals 4. So we get 4 plus 2 over 3 plus 1 should be equal to 3 times 4 over 2 minus 3. Okay, 4 plus 2, that's 6, over 3 plus 1 should be equal to 12 over 2 minus 3. Okay, on the left side here we have 6 over 3, that's 2 plus 1. And that should be equal to 12 over 2, 6 minus 3. And of course, 2 plus 1, that's 3. 6 minus 3, that's also 3. And it checks out. Okay, for our next problem, let's try this. X over 8 minus x plus 4 over 4 equals minus 1. If you'd like to try this problem on your own, you can shut off the videotape machine, work it out, and then turn it back on when you're finished. All right, what we're going to do is multiply through both sides of the equation by a number so that we'll clear fractions. Now, if you use the product of the denominators 32, it's really much more than you need. Actually, 8 is enough. If you multiply both sides of the equation by 8, you will remove fractions. Okay. 8 times x over 8 minus x plus 4 over 4 equals 8 times minus 1. Okay, now using the distributive law, 8 times x over 8, take away 8 times x plus 4 over 4 equals 8 times minus 1, or minus 8. Now, 8 times x over 8, the 8's go, we just get x. Take away 8 divided by 4, that's 2, times x plus 4 equals minus 8. Now, here we have to use the distributive law once again. We get x. Now, minus 2 times x, that's minus 2x. Minus 2 times plus 4, that's minus 8, equals minus 8. Okay, let me just write down what we have. We have x minus 2x minus 8 equals minus 8. Okay, now x minus 2x, that's minus x. Minus 8 equals minus 8. We can add 8 to both sides of the equation. This will give us minus x equals 0. And this is the same as minus 1x equals 0. Dividing both sides by minus 1, you get x is equal to 0 over minus 1, and that is just 0. Remember, you cannot divide by 0, but 0 in the numerator is perfectly okay. 0 divided by some non-zero number gives you 0. And this can be checked as the other ones. Now, the last problem that we're going to work out is one with decimals. And this is very similar to working out a problem with fractions. In fact, I'm going to do it both ways. OK, the one we want to work out is this. 0.9x minus 0.3 times x plus 2 in parentheses equals 3. OK, now, turning this into a problem with fractions, 0.9 is the same as 9/10. 9/10 x take away 3/10 times x plus 2 equals 3. Okay, now if there were fractions, it would be no problem. Everybody would know that you'd have to multiply both sides of the equation by 10. Let's do that. 10 times 9/10 x take away 3/10 times x plus 2 equals 10 times 3. This would give us 10 times 9/10 x take away 10 times 3/10 times x plus 2 equals 30. We're distributing the 10 through the brackets. 10 times 9/10 x take away 10 times 3/10 x plus 2 equals 10 times 3, or 30. Now, here we see the 10s will cancel. We'll get 9x. Here also the 10s will cancel. So we get 9x minus 3 times x plus 2 equals 30. 9x minus 3 times x plus 2 equals 30. Now, actually, we can get to this step a lot quicker. Let's go back to the original equation. We had 0.9x, 9/10 x, minus 0.3 times x plus 2 equals 3. Okay, all you really have to do to go from this step to this step is to multiply through both sides of the equation by 10. If you remember, when you multiply a decimal, okay, by 10, it has the effect, when you multiply a number by 10, it has the effect of moving the decimal place one place to the right, decimal point one place to the right. For example, 10 times 3.4 gives you 34. When you multiply a number by 10, it moves the decimal point one place to the right. 10 times 0.4 would give you 4. OK, so proceeding in that way, we could go right from this step to this one. We multiply both sides of the equation by 10. OK, 10 times 0.9x minus 0.3 times x plus 2 equals 10 times 3. We multiply both sides of the equation by 10. OK, now using the distributive law, 10 times 0.9x gives you 9x. Take away 10 times 0.3 gives you 3 times x plus 2. 10 times 3 gives you 30. OK, now you don't multiply the 10 times the 0.3 and then the 10 again times the x plus 2. Remember, there was no problem when you were dealing with fractions over here. Here it made sense. If you're multiplying by 10, you multiply this by 10 and this by 10. So when you're multiplying by 10, the 10s go. You're just really multiplying the 3/10 by the 10. Then you multiply the result by x plus 2. You don't distribute the 10 through here. You don't say 10 times the 3/10 times 10 times the x plus 2. OK? Here you just multiply the 3/10 times the 10 and then the result by x plus 2. The same thing over here. 10 times the 0.9x gives you 9x. Take away 10 times the 0.3 gives you 3 times x plus 2 equals 30. OK, so whether you did it with fractions or decimals, and of course the decimal way is easier, you get to this point. And we can finish off this equation the usual way, 9x. Now distributing the minus 3, giving you minus 3x minus 6 equals 30. This is 6x minus 6 equals 30. We can add 6 to both sides of the equation, giving 6x equals 36, and then divide both sides by 6, giving a final answer of x equals 6. Okay, let's also check this answer. To check it, we'll go back to the original equation and substitute in the value x equals 6 and hope that we get a true statement. Okay, substituting in x equals 6, we get 0.9 times 6, take away 0.3 times 6 plus 2 equals 3. It should be equal to 3, rather. And we're working with the left side and hope that it comes out to be 3. Now, 0.9 times 6 is 5.4. 9 times 6 is 54, and you have decimal place there. Take away 0.3 times 8 should be equal to 3. This gives you 5.4. Take away now 3 times 8, that's 24, and you have a decimal point here. This should be equal to 3, and of course 5.4 take away 2.4 gives you just 3. 3 equals 3, and the problem checks out. Well, this brings us to the end of this videotape. If you have any questions, you can consult with a tutor in the math lab or view the videotape again.